Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from current electricity chapter. Our first question is: three resistors having resistance R1, R2 and R3 are connected as shown in the circuit. The ratio of currents in terms of resistance used in the circuit is. Okay, so he gave a circuit where he connected three resistors R1, R2 and R3 in this form. Okay, where R2 and R3 are in parallel. Okay, that is R2 and R3 are in parallel. Now what he is asking us to calculate? He is asking us to calculate the ratio of currents. Okay, now if you observe this circuit, it is clear that the current I1 that is passing through R1 is being split into I2 and I3. Okay, now what did he ask us to calculate? He asked us to calculate the ratio of currents. Now, if you use the concept of division of currents in resistor connected in parallel, we can write current flowing through I3 as, so it is I1, it is I1 that is being split into I2 and I3. So now I1 will be my total current. Okay, so the current flowing through I3 will be equal to opposite parallel resistance, that is R2 into total current, which is I1, by sum of two parallel resistance, that is R2 plus R3. Okay, R2 plus R3. From this I can write I3 by I1 as R2 by R2 plus R3. Okay, so the answer is our first option. Okay, this is using a shortcut. If you want to do directly, then see, now this is the point where current is being split. Now if you apply a Kirchhoff first law, I can write the incoming current I1 is equal to sum of outgoing currents, that is I2 plus I3. Okay, that is first one. Let me take this as equation 1. Now then these resistors R2 and R3 are parallel. That means the potential drop across R2 will be equal to potential drop across R3. That is I2 R2 is equal to I3 R3. Okay, from this I can write I2 as I3 into R3 by R2. Okay, let me take this as equation 2. Now if I substitute equation 2 in equation 1, then I'll get this answer, that is I3 by I1 is equal to R2 by R2 plus R3. Okay, so now let us move to okay, he gave two columns. This is column 1 and this is column 2. He asked us to match. Okay, first drift velocity. Let us see about the drift velocity. If you go to the derivation of drift velocity can be written as Vd is equal to average thermal velocity plus A tau. Okay, average thermal velocity plus A tau, similar to V is equal to U plus AT. Okay, A plus AT, where A is the acceleration to which the electron is being subjected in a wire. Okay, AVG, this is the average thermal velocity, and we know that the average thermal velocity will be 0, and the formula for acceleration is A is equal to minus E by M. Okay, where E is the charge of electron, capital E is the intensity of electric field, M is the mass of the electron. Now if I substitute this, what will I get? Drift velocity Vd is equal to minus E by M into tau. Okay, so if you neglect this negative sign, so drift velocity can be written as E by M into tau. Okay, now let us see about electrical resistivity. The formula that connects this current density and the electric field is J is equal to sigma E. Okay, where sigma is the conductivity. Okay, now the relation between electrical resistivity rho and sigma is rho is equal to 1 by sigma. If I substitute this here, what will I get? J is equal to 1 by sigma into E. Okay, that implies electrical resistivity, J is equal to 1 by rho into E. Okay, that implies electrical resistivity rho will be equal to E by J. Okay, now let us see about relaxation period. Okay, we know the formula for resistivity as rho is equal to m by N.E. square tau. Okay, where tau is the relaxation period. Now if I interchange these two, what will I get? Tau is equal to m by N.E. square rho. Okay, so the formula for relaxation period is m by N.E. square rho. Okay, next, current density. The formula that connects current and drift velocity is I is equal to NEAVD, where VD is the drift velocity, A is the area, I is the current, N is the number of electrons flowing per unit volume. Okay, so now I'll bring this A down, then I can write like this: I by A, which is nothing but J, current density, is equal to NEVD. So the formula for current density is NEVD. Okay, so for A it is R, for B it is S, for C it is P, and for D it is Q. So option is fourth option. Okay, now let us move to our next question. Okay, our next question is the effective resistance of a parallel connection that consists of 4 wires of equal length, area of cross section and same material is 0.25 ohm. What will be the effective resistance if they are connected in series? Okay, now let us see what he gave. He told that he took 4 wires, okay, and the length of the wire and area of cross section of the wire are equal, and they are made up of same material. That is, since material is same, that means their electrical resistivity rho will also be same. Okay, so now L is constant, A is constant, and rho is also constant. Okay, we know the formula for resistance as R is equal to rho L by A. Okay, now since these three are constant, that is their resistance will also be constant. That means these 4 wires have same resistance, that is R is constant. Now what did he say? He told that these 4 wires whose resistance are equal, when they are connected in parallel, its equivalent resistance is Rp is equal to 0.25 ohm. Now what he is asking us to calculate? He is asking us to calculate Rs, which is nothing but the equivalent resistance when these 4 resistors are connected in series. Okay, for this we have a formula, that is a shortcut, that is Rs by Rp is equal to N square by 1. Okay, when will you use this formula? Means when you have n resistors of equal resistance, if they are connected in a series, then let us take its effective resistance as Rs. And if the same n resistors, if the same n equal resistors, when they are connected in parallel, then its effective resistance is Rp. Okay, then the ratio of Rs by Rp will be equal to N square by 1. Now in this case we have 4 resistors, we have 4 wires, so N is equal to 4. Now he gave us Rp, you have to calculate Rs. Okay, so if I use this formula, I can write like this, that is Rs by Rp, that is 0.25 is equal to N is equal to 4, that is 4 whole square by 1. That implies Rs can be written as 16 into 0.25, that is equal to 16 divided by 4, that is 4 ohm. Okay, so this is how we will use this solve this sum using this formula. Okay, if you want to do in general way, now we came to conclusion that the resistance of these 4 wires are equal and these 4 are connected in parallel. Okay, now if I use the parallel combination, I can write like this, that is 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus 1 by R. That is a parallel combination thing. Then that implies Rp will be equal to R by 4. Okay, that implies he gave Rp as 0.25. That implies R will be equal to 0.25 into 4, that is 1 ohm. Okay, now these resistors whose resistance is 1 ohm are connected in series. Then the formula for effective resistance is Rs is equal to sum of individual resistance, that is 1 plus 1 plus 1 plus 1, that is equal to 4 ohm. Okay, so the effective resistance when these four resistors are connected in parallel is 4 ohm. That is our third option. Okay, now let us move to our next question. In a potentiometer circuit, a cell of EMF 1.5 volts gives balancing point at 36 centimeter length of wire. If another cell of EMF 2.5 volts replace the first cell, then at what length of wire the balancing point occurs? Okay, so what did he give? This is a potentiometer circuit. In this potentiometer circuit, he used 1.5 volts in the secondary circuit, and he told that the balancing length is 36 centimeters. Okay, that means this is my balancing point. Okay, let me take it as C. Now what did he do? He replaced this 1.5 volts with 2.5 volts. Okay, now what is the new balancing length? L2. What is the new balancing length? Okay, now if you think about 1.5 volts, since this is the balancing point, that means for 1.5 volts in the secondary circuit, the potential drop across this is equal to 1.5. Okay, so now what did he do? He replaced 1.5 with 2.5. That is, he increased the potential. Okay, since he increased the potential, then the balancing point will be somewhere towards right only. Okay, because the potential drop should also increase, no? That means the balancing point will be towards right. That means the balancing length L2 will be greater than 36 centimeters. That means no point of saying that first option is correct. So first option is wrong. Since the balancing length is should be greater than 36 centimeters, so you won't get this as answer. Now if you see other options, they are close and they are greater than 36 centimeters. Then you have to go to general concept. That is, here we use the concept of comparison of EMF of two cells. Using that concept, we can write as E1 by E2 is equal to L1 by L2, where E1 is your 1.5 volts, E2 is your 2.5 volt, is equal to L1. First balancing length, that is 36 centimeter. L2 is your next balancing length. That's what you are supposed to find. Okay. From this L2 can be written as L2 is equal to 36 into 2.5 by 36 into 2.5 by 1.5. That is equal to 36 into 2.5 can be written as 5 by 2. 5 by 2 by 3 by 2. This 2 will get cancelled. This 12 times. That is equal to 60 centimeters. Okay, so the new balancing length is 60 centimeters, which is greater than 36 centimeters. Okay. If you feel that this video is useful, kindly share to your friends. Okay. If you have any doubts or suggestions, comment me in the comment section. If you didn't subscribe to my channel till now, kindly subscribe my channel. The only thing that I expect from you is a single like, because your single like or a comment that you give will encourage me a lot and makes me to make better videos.